Okay, today we're talking about solving quadratic equations. So we just got finished learning how to factor quadratics. Now we're going to solve quadratics. The very first point that I'll make is that there is a difference between factoring a quadratic and solving a quadratic. So of course you need to know that difference, and that means you need to know the vocabulary of those different terms. Quadratic equations. Problems involving area can result in a quadratic equation. So there's the geometry connection right there. Our whole unit has been about area. And we now see why we've learned about quadratics these last few days. A quadratic equation can be written in the form ax squared plus bx plus c equals 0. So this form that you see right here is what we would refer to as standard form or general form. We have the squared term first, followed by the x term, then the constant, and it equals 0. This is the format we want our quadratic equation in before we start to solve it. One method for solving a quadratic equation is to factor and then use what's called the zero product property. And the zero product property says to set each factor equal to 0 and solve for the variable. All right, so here's our first example. X squared minus 2x equals 24, and we're being asked to solve, so we're solving for x, the variable. Now, we know this is a quadratic because we see that the leading coefficient, or the highest degree, is 2, so that's a quadratic. But we also need to recognize that it is not in that standard form, so we need to put it in standard form. X squared followed by the x, then the constant, equals 0. So what we need to do here is subtract 24 from both sides of the equation. When we subtract those, we get x squared minus 2x minus 24 equals 0. Now we're in standard form. The next step is to factor the quadratic. So that's what we've been learning the last few days. So we apply what we've learned. Notice I'm going to keep this equal to 0. I look at my second sign. It's negative. So I know that that means I automatically have a plus and a minus as my signs. Factors of x squared are x and x. So I put those in the first spot in each binomial. Now factors of 24, we know that there's a bunch of them here, so we can list them out to help us if we need to. 24 times 1, 12 times 2, 8 times 3, 6 times 4. So we need to choose the right factors that will combine to give us a negative 2x as that middle term. So we're going to use the plus 4 and the minus 6, and again, understanding that with that FOIL method, those outside-inside terms are combining us to give us the negative 2x. Now that we've factored the quadratic, we apply that zero product property that says take each factor and set it equal to 0. And we end up with two very simple equations that we can solve for x. X plus 4 equals 0. If we subtract 4 from both sides of the equation, we get x equals negative 4. X minus 6 equals 0. If we add 6 to both sides of the equation, we get x equals positive 6. So we end up with two solutions for x, two values for x. As with algebra, you could plug those back into the original equation, make sure that they satisfy, and confirm that these are indeed your solutions for x. So we here have the quadratic 5x squared minus 33x plus 40 equals 0. We see that it's already in that standard form, so we're ready to factor it. There's no GCF to factor out because 5, 33, and 40 don't have any common factors. So I set up my parentheses. Keep them equal to 0. Second sign is positive, so whatever the first sign is, it goes in both. So I have two negative signs. Factors of 5x squared, well, 5 is a prime number, so we have 5x and x. And now factors of 40. So 40 and 1, 4 and 10, 8 and 5, 20 and 2. I don't know if there might be one that I'm missing, but I also know that I have the one that I want right there. So I need to get this middle term to be negative 33x. So again, using my understanding of the FOIL method and that the outside-inside will combine to give me that, if I use the 8 and 5 combination, and I put the 5 right here, it will multiply by that 5 to give me negative 25x. And if I put the 8 right here, it will multiply by this x to give me negative 8x. And those will combine to give me negative 33x, which is what I want. Okay, Grace? So now that I've factored it, I'm ready to use the zero product property. So I take each factor, set it equal to 0. Now the one on the right is the easier one. Add 5 to both sides. This one, 5x minus 8 equals 0. I have to add 8 to the other side and then divide by 5. So x equals 8/5. So again, we end up with two solutions. If we really wanted to double check, we could plug them back into the original quadratic and make sure that it satisfied the equation. But I like those two answers, 8/5 and 5. So last example, 2x squared plus 7x minus 4 equals 0. It's a quadratic. It's already in standard form. We're ready to factor it. Second sign is negative. I automatically have a plus and a minus. Factors of 2x squared are 2x and x. Factors of 4 could be 4 and 1 or 2 and 2. We need to decide which one to use. Remember, the outside inside is going to combine to give us that positive 7x. So in this case, I know that if I do 4 times 2, that'll give me 8. And then 1 times 1 will give me 1. 8 minus 1 would give me 7. So I'm going to go 4 here and 1 here. But we need to be careful because this will give me negative 8x. This will give me positive x. That would give me a negative 7x, but I want a positive 7x. So I better go back and switch my signs. I like where my numbers are. I like where my terms are, but I better switch the signs. I'll make this the plus, and we'll make this the minus. Now we're ready to set our factors equal to 0 and solve. Here I'm going to add 1 to the other side and divide by 2. So x equals 1/2. And here I'm going to subtract 4 and get x equals negative 4. So again, two solutions, 1/2 and negative 4. In some cases, you also need to be aware of this. Since we will be applying this to a geometry problem, in some cases, a negative number may not make sense in the context of a problem. Like if we're talking about side lengths of rectangles or something, obviously negative 4 couldn't be a side length of any shape. So keep that in mind also as we move forward.